Surds and Indices for AS A-Level Module C1. This video is going to be based on exam questions from the past 3 or 4 years, all about surds and indices. This is the index page, which you can get to any time by pressing the index button, and you can go to any of the questions by pressing the question buttons on YouTube. There's going to be a recap section to start with. You can skip that and go straight on to the questions and maybe come back to that if you're not sure about something, or you can maybe want to watch that to start with. All the questions are going to be in a PDF that you can find in the description below. So if you want to print it out and practice the questions and then come to the video, that's probably the best way of dealing with this sort of practice. So let's get on with the questions. Okay, we're going to recap surds for AS level, A-level maths, unit C1. Okay, so this video is going to have lots of questions on surds, and just need to go through a few of the basic rules that we need to be aware of. First of all, the first thing we need to know is that when we do the square root of something, so for example the square root of 3 times the square root of 12, that's going to be the same as the square root of 3 times 12. This is one of the key rules in surds. Also, if we can think of a number like this and we can break it up into two numbers, we can separate it into two separate surds. And that gives us the square root of 36, and we should know the square root of 36 is 6. So we can do results like that where we're combining two surds by multiplying, and we get a nice simple number at the end. The next sort of general thing we need to be aware of is simplifying surds. So if we've got square root of 50, for example, that's a classic one to simplify. Now, when we're simplifying surds, we're always looking at the square numbers, so 4, 9, 16, 25, 36, and so on. So when we're trying to simplify this, we're looking to try and break it up into two separate surds where one is a proper square number, square root of a square number. So 50 is 25 times 2. Then using this rule backwards, we've got the two numbers here, we can split them up into two separate surds. We get the square root of 25 times the square root of 2, and the square root of 25 is 5, and the square root of 2. So we're simplifying that into its base surd, which is root 2. The reason why we do that is then if we have another square root, for example, let me think of one, 18, which is 9 times 2, we get another, let's actually do that, square root of 18 equals the square root of 9 times 2, which is square root of 9 times the square root of 2, which is 3 root 2. So if I was adding the square root of 50 and the square root of 18, they may look like they can't be combined, or maybe you think they can. But the reason they can be combined is because we've got 5 lots of root 2 and 3 lots of root 2. So we could add those together to make 8 lots of root 2. Okay, other things that we need to be aware of. We need to be aware of this. If we have, similarly to this multiplication rule, if we have a division, so we've got the square root of 3 over 4, that's the same as the square root of 3 divided by the square root of 4. And we could simplify that to be the square root of 3 over 2. The next sort of thing we need to be aware of is rationalising denominators. So if we are given a surd such as 6 over root 3, for example, then this surd on the bottom makes this awkward to manipulate. So to rationalise that, we just times by the root 3, top and bottom, so we find an equivalent fraction, and we get rid of the square root, because root 3 times the root 3 is a square root of 9, which is just 3, and we've got 6 root 3 on top. And then we can actually cancel this 6 and this 3, because 3 goes into 6 twice, to leave us with 2 root 3. So that awkward looking surd with the surd on the bottom is the same as 2 root 3. The slightly more complicated version of that is if we have the same thing but we've got a surd plus a number on the bottom, then we have to do this thing which is based on the difference of two squares. To get rid of the surd, we can't just multiply by root 3, because then we'd end up with 1 times root 3, which is another surd. So if we manipulate this by timesing by the same surd but with a negative symbol in it, then what we're actually doing there is applying the difference of two squares, because we'll end up with this root 3 squared minus 1 squared. If we multiply out the brackets, we could do it the long way around, so we get root 3 times root 3, which is just 3. 1 times root 3 minus 1 times root 3, and that's why we do it, because the root 3's cancel. And then we've got plus 1 times minus 1, which is minus 1. Then on the top we've got 6 lots of root 3 and 6 lots of minus 1, which is 6. So we've got 6 root 3 minus 6 all over 2. And 2 goes into both of those 3 times. So we've got 3 root 3 minus 3. So this awkward fraction with the surd on the bottom can be simplified to something that's not quite so awkward, but with no surds on the bottom of the fraction. And the last sort of skill we need to be able to do is to multiply out brackets with surds. So for example, if I had root 3 plus 2 times by root 2 minus 1, we need to be able to multiply that out. And it's just the same as a single bracket. We can do the FOIL method, where we do the first and then the outer, and then we do the inner, and then the last two. Sometimes call this a smiley face method because it looks like a bit like a smiley face. Or you can use a grid method if that's what you use. But as long as you remember to multiply all the terms, we get root 3 times root 2, so that's root 3 times root 2, plus root 3 times minus 1, which is minus root 3, 2 times root 2, which is plus root 2, and 2 times minus 1, which is minus 2. And just simplifying that a little bit, this is going to be the same as the square root of 6, plus root 3, plus 2 root 2, minus 2. So it's just like multiplying out an ordinary brackets with letters, for example. If that was the letter A and that was the letter B, this would look very similar to a standard multiplication of brackets. So those are all the basic rules we need to be able to do, and skills we need to be able to deal with most surd questions. When we look at indices, we have all the basic indices we knew from GCSE maths. For example, 4 squared times by 4 cubed is the same as 4 to the power of 2 plus 3, which is 5. And then if we have a division 1, doesn't matter how it's written, so if we have 4 to the power of 8 over 4 to the power of 3, which could be written as 4 to the power of 8 divided by 4 to the power of 3, then we subtract the powers to get 4 to the power of 5. And then if we've got powers of powers, so if we've got, say for example, 4 to the power of 2 to the power of 3, then that's the same as multiplying those powers. So we've got 4 to the power of 2 times 3, which is 6. That becomes from, because we've got 4 squared times 4 squared times 4 squared, because that's 4 squared cubed, which is 4 to the power of 6. Other rules that we should be familiar with, we should be familiar with the fractional powers. So 4 to the power of half means the square root of 4, which is 2, or 8 to the power of a third would be the cube root of 8, which is also 2. Negative powers, so if we have 4 to the power of minus 2, the minus means the reciprocal of the normal power without the minus, so 4 squared, so the reciprocal of 4 squared is 1 divided by 4 squared. Or if we had as a fraction, say 2/3 to the power of minus 2, when we do that, to reciprocate a fraction, we turn it upside down, so we get 3 over 2 to the power of 2. So those are pretty much the basic rules. Now we extend upon them in A-level maths to make it more complicated, or be able to deal with more complicated situations. Other things we like, a little bit like this surd rule here, because essentially square root is just at indices. So we've got 4 to the power of 9, 4 ninths to the power of a half. That would be the same as 4 to the power of a half over 9 to the power of a half, which is the square root of 4 over the square root of 9, which is just 2 over 3. So those are the sort of things that we need to be aware of. And for most surds, because it's non-calculator, we're only going to be dealing with powers of 2. So 2, 4, 8, 16, 32, 64, 128 and so on. The powers of 2 are fairly easy to work out and should be fairly recognisable. Powers of 3, probably up to 81. You might be able to, might go to the next ones, 2, 4, 3, but powers of 4, probably only up to 64. Powers of 5, 1, 2, 5, and then any power of 10. So all the powers of 10, because they've just got lots of zeros on, you should be able to spot fairly easily. So most of the numbers we deal with in indices are these numbers here. There's very rarely any numbers outside of these. So if you get familiar with these, especially the powers of 2, because they're always used, you should be fine with most of the indices questions, because you'll notice what they're going to be before you do them. One last thing that I want to touch on is something like this, where you've got something times a power, and then you've got that to a power. So this time we've got a letter power here, so the cube of this is the same as each bit cubed. So we've got 3 cubed times x squared cubed. So that's 3 cubed, which is 27, and x squared cubed would be x to the power of 6, because we just times the power of 2 times 3. Okay, so that's pretty much all the rules we need to be aware of for surds and indices. Okay, question 1. Now I'm not going to spend too long explaining how to do these questions. If you're not sure, you can go back to the index and use the recap section to help you if you'll find it a bit difficult. Okay, so to start off, we've got to simplify 2 square roots. When simplifying surds, we're really thinking about what square numbers go into this number. Now this number is 16 times 2, and 16 is a square number. So that's the same as the square root of 16 times the square root of 2, which is 4 root 2. If we're going to combine them with a plus, this one's going to be based on root 2 as well. So root 18 is 9 times 2, so 9 is a square number. So a lot of these surds questions, well, all these surds questions, when you're simplifying stuff, you're looking for square numbers that allow you to square root them to get a proper number. So we end up with 3 root 2 and 4 root 2, and if we're adding those together, we get 3 root 2 plus 4 root 2, which is the way around, 4 root 2 plus 3 root 2, doesn't matter though, which is 7 root 2. And that's worth 2 marks. So the form a root 2 just means there's a number, a whole number, integer in front of the square root. Okay, so simplifying this, a little bit more complicated situation. When we've got a fraction type question where we're trying to simplify, actually what we're trying to do is get rid of anything on the bottom, any of the surds on the bottom. In fact, it wants it in the form b lots of root 2 plus c, where b and c are integers. And this is also based on this starting bit. So we know root 32 plus root 18, we should know that's 7 root 2. So we can start by putting 7 root 2, that should make life a little bit easier. And to get rid of this, deal with this denominator, we need to multiply by the same thing but with a minus sign. That allows us to get rid of the square roots because it's based on the difference of 2 squares, and you'll end up losing the square roots when you multiply it out. So let's just run through that. So when we multiply this bottom bit out, essentially we're just going to do 3 times 3, which is 9, and we're going to subtract root 2 times root 2, which is square root of 4, which is just 2. The other terms, root 2 times 3 and minus root 2 times 3, cancel, and that's why we use this format, this difference of 2 squares idea, to get rid of the middle terms. So we've got 7 root 2 times 3, which is 21 root 2, and then 7 root 2 times minus root 2, which is going to be minus root 2 times root 2 is square root of 4, which is 2, so we've got 7 times 2, which is 14, and that's all over 7. And quite simply for us, this cancels nicely, so 21 divided by 7 is 3 root 2. When we're doing this, we must divide both terms, so we've got to divide this one as well. 14 divided by 7 is 2, so we've got 3 root 2 minus 2. So there's our b and c, so b equals 3 and c equals minus 2. It doesn't actually ask you to put what b and c are, just in the form, so that's the real answer. But sometimes it asks you for the actual letters, you can do that. Okay, so that's the first question done. Okay, question 2. This time another, it's just going straight into the simplifying with a fraction or quotient. So we just need to multiply the top and bottom by the same thing as the bottom, but with the sign change. So if this is a minus sign, we put a plus sign. If this is a plus sign, we put a minus sign. And the reason we do that, as I explained it before, is to get rid of the square roots from the bottom, because that's what will happen if we do this. So we end up with 5 minus 2 root 3 times by root 3 plus 1 on the top. So we're going to multiply out that double bracket. And this bit on the bottom, we've got root 3 minus 1 times by root 3 plus 1. So the top bit is a skill that's a little bit tricky, but as long as you think about all the 4 terms that you get when you multiply double brackets, you should be fine. So if we do the first term, 5 lots of root 3, the outer terms, the outer term, so 5 times 1 is plus 5. The inner terms, so we've got minus 2 root 3 times root 3. So we've got minus 2 lots of root 3. I'll come back to that in a minute. And minus 2 lots of root 3 times 1, so that's minus 2 lots of root 3, because 1 times anything is just itself. Okay, on the bottom now, this you don't really need to multiply this out. You should know this sort of form where you have this number squared minus this number squared. So root 3 squared is the square root of 9, which is just 3. And then we're going to take away 1 squared, which is 1. Okay, so let's simplify the top. So this can be simplified, and that's probably, and then we can add it to the 5, because root 3 times root 3 is the square root of 9, which is 3, and 2 lots of that is 6. So let's take away 6 minus 2 root 3. So we've got 5 root 3 minus 2 root 3 is 3 root 3, and plus 5 minus 6 is minus 1. And on the bottom, we've just got 2, so that's over 2. So we want it in the form like this, where p and q are rational numbers. In this case, that means fractions. So we're dividing by 2, so 3 root 3. Actually, what's the p first? So let's do the minus 1. Minus 1 divided by 2 is just minus a half. And then we're going to add 3 over 2 root 3, because we're dividing 3 by 2. Okay, so that's our format for that question. Question 3 and 4, some more Surds questions. This one, expanding the double brackets, it's just like completing the bottom part of a rationalising denominator question. But I'm going to show you how you could do this in a different way. If you're not too good with the FOIL sort of method, if you want to have a different method, we can use a grid method where we've got root 7 times 2 plus 2 and root 7 minus 2. And this gives us our 4 multiplications we need to do. Root 7 times root 7 is the square root of 49, which is also 7. 2 lots of root 7 is 2 root 7. 7 lots of minus 2 is minus 2 root 7. And 2 lots of minus 2 is minus 4. These two ones are going to cancel each other, because one's a plus 2 and one's a minus 2. So we're left with 7, the square root of 49, minus 4, which is just equal to 3. So the answer to this one is just 3. Could have done that a bit quicker if we were familiar with this format. We just need to square 7, root 7, which is 7, and take away 2 times 4, 2 times 2, which is 4. Okay, question 4, simplifying surds. Once you've done a few of these, you get to get very familiar with the numbers they use in these. There's not many different combinations we can use for the square root of numbers. What we're looking for is a square number that goes into 75, so that's 25 times by 3. 325 is 75, so it's the square root of 25 times the square root of 3. Now, I'm stepping out this question in lots of steps. I could just go straight to the answer, but just to make it nice and clear, square root of 25 is 5, times root 3 is 5 root 3. I mean to do the same for the square root of 27. Now, the square number that goes in 27 is 9. 9 times 3, square root of 9 times square root of 3. Square root of 9 is 3. So we've got 3 lots of root 3, so we've got 5 root 3 minus 3 root 3 is equal to 2 root 3. Okay, question 5 and 6. We've got another pair of Surds questions. And you'll see these questions being very similar each time. Then we've got our first of our index questions, indices. So the first one, multiplying out this bracket. So you could use whatever method you want. I'm just going to talk you through each step. So 7 times 3 is 21. 7 times minus 5 is minus 7 root 5. Root 5 times 3 is plus 3 root 5. Always put the number in front of the square root. And then root 5 times minus root 5 is minus root 5 times root 5 is root 25. And the square root of 25 is in fact 5. So we've got 21 take away 5, which is 16. Nearly put 6 there. Root 7 minus 7 root 5 plus root 5, 3 root 5 is minus 4 root 5. So that's the first section. Okay, second part, B. So this is going to rationalise the denominator. To do that we need to times by the bottom part, but with a change in sign. So we've got 3, this is plus root 5, so we need to times by minus root 5. And we do the same to the top, 3 minus root 5. And surprise, surprise, this looks exactly the same as part A, which is quite, it saves a bit of time. Because we know that the top is 16 minus 4 root 5. And the bottom is just going to be the difference of the two squares. So 3 times 3 is 9, minus root 5 times root 5, which is 5, so that's just a 4. So we've got 16 minus 4 root 5 divided by 4. So that gives us 16 divided by 4 is 4, and 4 root 5 divided by 4 is just the square root of 5. So that's the form where A is 4 and B is just going to be minus 1, but we don't put minus 1. Okay, find the value of 25 to the half. So powers of a half, or fractional powers, a half is the same as a square root, a third is the same as a cube root, and so on. A fourth is the same as the fourth root, and so on. So 25 to the power of a half is just the same as the square root of 25, which is 5. Okay, and now we've got to do the same thing but with a minus power of a fraction. This is a bit trickier. So the minus means the reciprocal of 25, the reciprocal of 25, so 25 to the minus 3 over 2. The reciprocal, the minus, makes it, when it's a whole number, you do 1 divided by that number. If it was a fraction, we would turn the fraction upside down. Essentially, we're actually considering 25 to be a fraction, 25 over 1, and then we turn it upside down to get 1 over 25. So that gets rid of the minus sign, so we've still got to do the 3 over 2. Okay, and what we're going to do there is we're going to break it down into two sections. We're going to do the bottom of the fraction first, so 1 over 25 to the half, and then we're going to do that to the power of 3. Because we should know when we've got a power of a power, that's just the same as multiplying the two powers, and if we multiply a half by 3 we get 3 over 2. So essentially what we'll do is we're breaking it down into two sections, the half and then the cube. So to the power of a half, that's just the square root. The square root of 1 is 1, the square root of 25 is 5. So that power of a half gives us 1/5. If you think about it, if you squared 1/5, you'd end up with 1 times 1 and 5 times 5, which will give you 1 over 25. And then we're going to cube it, so we've got 1 to the power of 3, which is 1, and 5 to the power of 3 is 1, 2, 5. Okay. Okay, questions 7 and 8. Slight variation on what we normally see here. Normally we have a number and a square root. I don't think that makes any difference though. And then we've got a third question in context, which should be interesting. So this one, simplify it. So we need to multiply root 12 minus root 8. We need to multiply by root 12 plus root 8, top and bottom, and that will get rid of the surds on the bottom. So on the top we end up with just 2 lots of root 12 plus 2 lots of root 8. On the bottom, which I'm not sure that was wise, we could have just left the 2 on the outside, but anyway, we end up with root 12 times root 12, which is just 12, and minus root 8 times root 8, which is just 8, so minus 8. So we end up, I'm actually going to put that 2 back out of on the outside of the bracket. We end up with 4 on the bottom, so that just cancels down, so to a 2 there, and that gets rid of that, so we end up with root 12 upon 2 plus root 8 upon 2. And we want a and b to be integers, so we want 2 square roots, so we need to take the 2 into the square root. Now we haven't seen that before, so what we can do there is 2 is the same as the square root of 4, so we can write that, and then we can then combine these to make 1 square root of 12 over 4, and the same for this one, 8 over 4. And 12 over 4 is 3, so square root of 3, and 8 over 4 is 2, so square root of 2. So it's 3, square root of 3 plus square root of 2. Okay, that's quite an interesting question, that one. Not your typical question, but you should be able to get to most of this, get most of the way through this. This last bit is untypical, so it might escape you to start with, but you should, once you've seen a couple of those, you should be fine. Write the square root of 80 in the form c root 5. So we're sort of given a clue here what this is going to be. So something times 5 is 80. So the square root of 80, well 80 is 16 times 5. And that's good because the square root of 16 is 4. So we've got 4 root 5. Okay, in part B we have a rectangle. R has a length of 1 plus root 5 and an area of root 80, and the width is R. So we've got R times the length, 1 plus root 5, equals the square root of 80. And we know the square root of 80 is 4 root 5, so let's just add that on the end. Now to get R, we need to divide by 1 plus root 5. So we've got R equals, I'm going to use this 4 root 5 divided by 1 plus root 5. So now we actually need to manipulate this because we want it in the form p plus q root 5. So we need to get rid of this surd on the bottom by multiplying by the same thing but with a different sign. So that's plus versus minus. So we've got 4 root 5 times 1, which is 4 root 5, and 4 root 5 times root 5, well, root 5 times root 5 is just 5, so we've got 4 5s are 20, so we're taking away 20 there. And on the bottom we've got 1 minus the square root of 5 squared, which is minus 5. So we've got 4 root 5 minus 20 divided by minus 4. And when we divide by minus 4, the 4 is going to cancel, and that's going to become a minus sign. And then that's going to cancel to be a 5, and that's going to become a plus sign. So we end up with minus root 5 plus 5, or 5 minus root 5, the better way of writing it round. So we've got it in the form p, which is 5, and q is just the number minus 1, root 5. There we go, question 7 and 8. Question 9 and 10. Another surd question and then an indices question. This surd question, we've got to solve an equation. So, and we're told to give the answer in the form a root b. So what we need to do, I think, to start with is get rid of this root 2 by multiplying through by the root 2. And then we can get the x's together. So if we multiply through by the root 2, we get 10 lots of root 2. Plus x times root 2 times root 8 is root 16, which is just 4, so that's actually 4x. So that's x root 8 times root 2, which is just the same as root 16, which is 4. Put the other way around, is 4x. And that gives us, that's equal to 6x. So now we can just take away the 4x, so we've got 10 root 2 equals 2x, and then we need to halve it, so divide by 2. We get x equals 10 divided by 2 is 5 root 2. So it's actually quite straightforward if you make that first step of multiplying by multiplying through by root 2, and don't make any errors with that. It comes out quite nicely. Question 10. Find the value of 16 to the power of a quarter. Well, powers of fractional powers, so power of a half, something to the power of a half is the square root. The power of a third is the cube root, so let's just say x, and then something to the power of a quarter is the fourth root. Okay, the only things we know the fourth roots are, maybe we know the fourth root of a power of 3, so it's 81. The fourth root of 81 would be 3. Maybe a power of 10, so the fourth root of 10,000 would be 10. But most of these ones with the higher powers are going to be 2, so 2 to the power of 4 is 16. So 16, the fourth root of 16 is going to be 2. Simplify this expression, so we've got x, 2x to the minus a quarter to the power of 4. The only thing I would say you've got to be careful with here, the rule is we multiply the power by the power when you do a power of a power, but we've got to be careful, we've got to do something with this 2. This 2 is also to the power of 4, so we've got x times 2 to the power of 4 times x to the minus a quarter times 4. So that's x times 2 to the power of 4, which is 16, times minus a quarter times 4 is just minus 1, so it's x to the minus 1, and x times x to the minus 1 is just 1 because they cancel each other out, so that's x to the power of 1. So we add the powers and we times them, so it gives us 0, which is just 1, so we're actually just left with the number 16. So that complicated thing there simplifies to 16. The most common mistake people will make was to forget to just leave this as 2 and not 2 to the power of 4. This bit is okay, I hope. Maybe the times minus 1 and the 1 might be a bit easy to make a mistake on, but hopefully you get to the answer 16. Question 11 and 12, both indices questions. I'll start with 32 to the power of 3/5. When you've got this fractional power where you've got a multiple of a fraction, so we break it down into 1/5 and 3. So we do the 5th power and then we do the cube. So 32 should be fairly familiar with you if you've done a number of questions. 32 is 2 to the power of 5, and 1/5 of 2 to the power of 5 is just 2, and we've got that cubed, which is 8. Be wary of all the powers of 2, 2, 4, 8, 16, 32, 64. So this is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. They are the most common ones for these sort of questions. Simplify fully this expression to the power of minus a half. Well, let's deal with that first. The minus bit means we take the reciprocal of the original, so what's inside the brackets gets turned upside down. That's what we do with the minus power, has that effect. So that's just the same as that. So the minus disappears and we just turn the fraction upside down. So power of a half means the square root, so we've got the square root of the top and the square root of the bottom. The square root of 4 is just 2. The square root of 25, we can break this down to the square root of 25 and the square root of x to the 4. Square root of 25 is just 5. And the square root of x to the 4, well, that's what number times by itself is x to the 4? Well, that's x squared. So we end up with 2 over 5x squared. Just for completeness, this could be written as 2/5 of x to the minus 2. If the x squared is on the bottom, that's the same as x to the minus 2, and the 2 over 5 is just 2/5. So it could be written like that, but this is perfectly fine. But if you want to break out the fraction and use a negative power rather than using a fraction with the power on the bottom, write down the value of 125 to the 1/3. Well, you should be familiar with powers of 5, 5, 25, 125. So that's 125 to the power of a third is the cube root of 125, which is just 5. Find the value of 125 to the minus 2/3. So the minus is 1 over 125 to the 2/3, and with the fractional powers we break it out into a fraction, so we got 1 over 125 to the power of 1/3, and then we do that to the power of 2, or square it. So to 1/3, well, we know 125, the cube root of 125, or 125 to the third, is just 5. The cube root of 1 is just 1, so that's just going to change to that, and then we want that squared, so we times the top by itself is 1 and the bottom by itself is 25, so 1 over 25. Okay, some more Surd questions, and then we've got some of these indices questions. Well, we've got to change the base power. I'll talk more about that in a second. So the first one here, 3 root 7 squared. Well, that's almost like an indices question as well. So we've got 3 root 7 times 3 root 7, which is 3 times 3 times root 7 times root 7. And that gives us 3 3s are 9. Root 7 times root 7 is just 7, which is 63. This one, multiply out these out, so we've got 8 times 2 is 16. 8 times minus 5 is minus 8 root 5. Root 5 times 2 is 2 root 5. And root 5 times minus root 5 is minus 5. Root 5 times root 5 is root 25, which is just 5. So we've got 16 minus 5 is 11. And minus 8 plus 2 is minus 6 root 5. Question 14. Given that 32 lots of root 2 is 2 to the power of a, find the value of a. So what we're trying to do here is we'll find the value of a that gives us this thing here. So 32, if we think about what power of 2 is 32, 32 is equal to 2 to the power of, let's just write them down, 2, 4, 8, 16, 32. So that's 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. Okay, and we're timesing that by root 2, and root 2 is 2 to the power of a half. So we're doing 2 to the power of 5 times 2 to the power of a half, and when we times powers we add them, so we get 2 to the power of 5 and a half. Okay, so a equals 5 and a half, or probably better to write it as a top heavy fraction, so we end up with 11 over 2. Here we go, one where we are changing the base power because we want this in the form of 2 to the power of something. We've got 8 to the power of something, so we know that 8 is 2 cubed. So if we replace that 8 with 2 cubed to the power of 2x plus 3, so the power of the power, we end up multiplying the power, so it's got 2, 3 times this would be 6x plus 9, so that's equal to 2 to the power of y, so y equals 6x plus 9. Okay, back to more Surds questions, multiplying out brackets, so 5 times 1 is 5, 5 times root 2 is 5 lots of root 2, minus root 8 times 1 is minus root 8, minus root 8 times plus root 2 is minus, let's just write that down as root 8 times root 2. So we've got 5 plus 5 root 2 minus root 8. Now root 8 will simplify, but I just want to deal with this one on the end here first. Root 8 times root 2 is root 16, and that's just 4. So this end bit's just 4. Root 8 itself is 4 lots of root 2. Root 4, sorry, 4 times 2, so that's the square root of 4 times the square root of 2, which is 2 root 2. So we've got 5 minus 4 plus 5 root 2 minus 2 root 2. So we've got 1 plus 1 plus 5 root 2 negative 2 is 3 root 2. Okay, so that's that first part. And now the second, express this in the form c root 5. Okay, so I need to just rule that off there. So root 80 plus 30 over root 5. Right, to combine that, first of all, let's look at root 80. Root 80 is, well, if it ends in 0, it's probably a multiple of 5, so that's, how many 5s 80? That's 16. So that's going to be square root of 16, which is 4 times root 5. Oops. And then we've got to do 30 over root 5, 30 over root 5. Well, to simplify that, I need to get rid of the root 5 on the bottom. So I times by root 5, top and bottom, so I get 30 root 5 over 5 root 5, which is just 5. And that cancels into 30 gives 6, so this is 6 root 5. So this is the same as 4 root 5 plus 6 root 5, which is 10 root 5. So that's our C, is 10. Okay, simplify this one. Standard sort of one where we times in the top and bottom by this root 5, and then we change the sign to plus 1. So root 5 plus 1. And that gives us 7 lots of root 5 is 7 root 5. 7 lots of 1 is 7. Root 5s are 5, and root 5 times 1 is root 5. And on the bottom we've got the square of root 5, which is 5, minus the square of 1, which is 1. So we end up with 7 root 5 plus root 5 is 8 root 5. 7 and 5 is 12, all over 5 over 1 is 4, cancel that down, 4's going to 8 twice, so 2 root 5, 4's into 12 go 3, so 2 root 5 plus 3. I wanted it the other way around, so just tidy it up, 3 plus 2 root 5. There we go. Okay, 2 questions on indices. 8 to the power of 5 over 3, so we break that down into 8 to the power of 1/3, so we take the bottom of the fraction, and then we times by, well, don't times, we take the power of 5 afterwards. So we're breaking up the 5 root 3 into the 1/3 and then to the power of 5. Because 8 to the power of a third is just 2, because that's the cube root of 8, and the cube root of 8 is 2, so 2 to the power of 5, well, 2, 4, 8, 16, 32, so that's 2 to the power of 1, 2, 3, 4, 5 is 32. Simplify fully this. Be careful with the top. When we do the power of 3, we must do 2 to the power of 3 and x to the half to the power of 3. So it's 2 to the power of 3. Then it's x to the power of a half times 3, all over 4x squared. So 2 to the power of 3 is 8. Half times 3 is x to the power of 3 over 2 over 4 to the power of x squared. So 8 divided by 4 is 2. And then we've got x to the 3 over 2 divided by x to the 2. So x to the 3 over 2 divided by x to the 2. So that's a basic rule. We just subtract the powers. So 3 over 2 minus 2, which is 3 to x over x to the minus a half. So that's 2 lots of x to the minus a half. Now that could be written as, in a different format, we could write that as 2 over the square root of x. X to the minus of x to the half is the square root of x. The minus means it's 1 over that, and times by 2 is 2 over that. But this is fine, this is where I would normally leave it, but that looks a bit neater. Changing the base number, so 8, what power of 2, well it's not really, what power of 2 is 8, so 2 to the power of 3 equals 8, so y equals 3, so that solves it, y equals 3. 2 to the power of x times 4 to the power of x plus 1 equals 8. Now the way we would do that is, the way I'll do that was I'd change the 4 to the base of 2, so 4 to the x plus 1, 4 is 2 squared to the x plus 1. So when we do a power of a power, we just times the power, so that's 2 to the power of 2 lots of x plus 1, which is 2x plus 2. So we've got 2 to the power of x times 2 to the power of 2x plus 2 equals 8, and 8 is 2 to the power of 3. So when we multiply powers, we add them, so we've got x plus 2x plus 2 equals 2 to the power of 3. So this top bit, x plus 2x is 3x plus 2 equals 3. Solve that, we take away the 2 to give x, 3x equals minus 1. No, it doesn't. 3x is not minus 1, 3x is just going to be 1. So 3x equals 1 because 3 take away 2 is 1. So x equals 1/3. That solves the question. Okay, last two questions. Two more indices questions. 81 to the power of 3 over 2. 81 to the power of 3 over 2. Well, we split the 3 over 2 into the power of a half times 3. So that's the power of a power. 81 to the power of a half is 9. And 9 to the power of 3, well, 9 squared is 81 again, and then we just times by the 9, so 981 is going to be 729. Simplify fully this expression, so we've got x squared times by this squared, so we've got the 4 has to be squared, and then the x, the minus a half, has to be squared. So that's going to be x squared times 4 squared is 16, times x to the minus a half squared is going to be x to the minus a half times 2 is minus 1. So that's x squared. Let's actually put the 16 at the front. So we've got 16 x squared times x to the minus 1. And when you times two powers, you add times two powers with the same base, you add the powers, so it's 2 plus minus 1 is just 1, so that's just x to the power of 1, which is x. Question 21, the last question I'm going to do for this topic. Write down the value of 32 to the power of the fifth. Should be very familiar with the number 32 now. It's the fifth power of 2, so that's just 2. Simplify fully this expression, so hopefully you're going to use that a little bit. So let's just start by doing the negative, which means 1 over 32 to the x to the 5, and then we want that to the power of 1/5, and then that squared. Okay, so power of 1/5, the fifth power of this, well, 32 is 2 to the power of 5, x to the power of 5, so let's actually write that more neatly as 2x to the power of 5, and then we want that to the power of a fifth, and then we're going to do all that squared. So it's the power of fifth when something's already a power of 5, that's just going to leave you with 2x. The fifth root of 1 is just 1 because 1 to any power is 1. So then we just need to square this, and then square 1 we get 1, square 2x we get 4x squared. So it's going to be 1 over 4x squared. We could write that as a fraction of x to the power minus 2, but that's a much neater way of writing it. So either of those are fine. There we go, we finished. 21 questions on surds and indices. Hopefully, if you've done all the questions, you should be very familiar with these sort of questions. They are the same numbers, because this is non-calculate, the same numbers turn up time and time again. So if you do a lot of them, you'll get very used to the numbers and therefore get very good at them.